The Herschel Space Observatory is without doubt one of the most impressive spacecraft ever built. With its telescope, the largest ever flown in space, and its unique ability to cover a wide range of the infrared spectrum, it will be the first to study the earliest phases in the formation of stars and galaxies. Following in the footsteps of ESA's ISO Infrared Space Observatory, the mission has taken 10 years to develop. It is named after the 18th century astronomer William Herschel, who discovered infrared light, light which our eyes cannot see, but which pervades the universe. The spacecraft is more than 7 meters in length, about 4 meters wide, but its dominant feature is the telescope, with a 3.5 meter diameter primary mirror, 4 times bigger than any previous infrared space telescope. Herschel will let astronomers probe the cold regions and objects of the universe. But to detect these cold objects, Herschel has to be even colder. The whole spacecraft, with its large sunshade and solar array, and its bulbous tank enveloping its 3 science instruments, has been designed to keep Herschel super cool. The observatory's heart is the cryostat tank, filled with 2,400 litres of liquid helium, which will cool the infrared detectors down to practically absolute zero, minus 273 degrees Celsius. The helium will gradually be depleted, but allowing at least 3 years of routine observations. The lower module of the spacecraft contains the data processing computers, communications equipment, navigation and attitude control systems that will allow the telescope to pinpoint its targets. Another unique feature of the observatory is its location in space. In orbit around the Earth, it would be affected by heat from our planet, the Moon, and from the Sun. So Herschel will, after launch, cruise towards a position 1.5 million kilometers from Earth, the so-called second Lagrange point, from an orbit around which it will have an unrivaled view of the whole sky. Like a thermal camera can see a person's body heat in the dark on Earth, Herschel will delve into visibly opaque clouds of dust and gas in space, the soup from which stars are formed. It will be able to study comets, the chunks of ice and dust left over from the formation of planets. And even further, it will look into the distant universe, where galaxies collide and give birth to hundreds of billions of stars.